Today is our 131st meeting, so I've been doing this a while now for people who are new. I have two things on the docket today. I had a presentation from Keysight around a hero test demonstration at full scale, and I also have Michael from the SDN team here willing to share afterwards. So I guess we can get started. And I'll go ahead and ask Keysight to go first. Marcia, did you want to take over the screen?
Sure, I will share.
Okay, great.
In a second. Let me know if it's visible.
I can see it, yeah.
Perfect. So this is a demo of the full hero test. We're gonna focus on the hero test itself and let's say and questions around this. I will not answer and we're not gonna discuss about the device is running against. Okay, so it's all about the test, not the device that is being tested. It's live. So if something crashes, some loss appear or something may happen. I don't know. So it's all live, but you know, it will be like a discussion so people can ask questions and I'll show things. So based on the hero test, we have three types of traffic. We have UDP connections, which are established and then they are left running. So it's all fast path and they will fill the flow table. There are 64 million connections, which will do 128 million flows. There will be TCP flows, which they start and then they send data to keep those connections alive for a very long time. And those are 60 million connections for 120 million flows. And there are 4 million flows which are left unused for the CPS part of the test for the measurement. And all these test ports that we see here are aggregated, added VXLAN, and the traffic is being sent over 400 gig ports for the total of 1.6 terabit of smartness, which is a requirement for the smart switch. UDP background happens over VNet direct. So it's many IPs, but all going to same, not same, but fewer MACs, which are like the gateway MAC for VNet direct, while all the TCP traffic goes over directly mapped IPs, which each IP has a unique MAC. And with that, basically we can see the UDP traffic started. Usually we start this one first because it's part of the background traffic and we want to have it running. It's already running. And the rate, I set it to, so if we say 128 million flows divided by 5, which is a flow timer based on the test, plus 10%. So that will be about 28 million packets per second being sent. Now, packet size is relatively small, and we'll discuss about this. The test requires to increase the bandwidth to about 80% for the background traffic and leave only about 20% for the CPS measurement. Usually when I start it, I just started with a low frame, so we can see total, we are far from 1.6 terabit. Yeah, it's 18 gig here. But once it started and we see everything running, we can increase the frame size and take more and more in bandwidth so we can see kind of bad things happen or not, and what's causing it. We also have, let's see, what is this? Background TCP traffic. So 60 million connections, which will make 120 million flows. And here, it's not packet rate, it's transaction rate. So because in TCP, we have to send the packet with data and we'll get an ACK back. So again, 60 million, 100 divided by 5, plus a 10%. So we are at 13.2 million transactions and we have 2 packets. Yeah, the data and the ACK for TCP. Now here, in order to increase the bandwidth taken by this test, we can increase the data size. But the ACK, it's going to be the ACK, just a small packet. So you kind of have to average it out and take that into account. So we can fill in the data packet and increase it, but the ACK is ACK. That's what it is. So we can average it out and see how much bandwidth this takes. And with this running, so we have both of them running, we can start the CPS test. I already started. By the way, this take a long time to get configured and so on. This is why they are pre-started. I started like an hour ago. And we can see here, basically, we get a connection rate, let's say, of 25 million CPS. Requirement for the test is 24. And so far, we see usually these are stats like TCP failures on either the client or on the server side. And we are looking to have none. Now, the failures can be all kind of two types. A retransmit, which still means a packet lost. Yeah, if you lose the packet, you retransmit. But you can also have timeouts where basically it retransmitted a couple of times, failed, and then you lose the connection. And those are really bad. And then usually what I looked at sometimes are latency, but the latency here, it's more like a whole communication latency. Let me see if I can show one of those views. This is not packet in, packet out latency. This is more like an app latency. The problem is at this increases, you will see concurrent connections that they don't close fast enough, lingering, and then you start piling up, even from the CPS test, connections one on top of each other. We have 4 million left of flows to be there. That's never going to get to 4 million. I mean, that will be terrible. Usually I see here in hundreds, thousands, kind of in that range. But the lower the latency is, the better. And then for latency, effective latency measurement, we can stop all the traffic and use a UDP, let's call it a fast path. UDP is very easy, and that we can get basically kind of nanosecond accuracy. And since the requirement it's around 2 microsecond packet in, packet out for Dash, yeah, we are well within margin of error here. So
within the boundary, yeah.
Yeah, I mean, this is 2.5, let's say, 2,500 nanoseconds, so 2.5 microseconds. So you can say, oh, it's a bit over. But it's good. So kind of this is a full hero test running and showing that it can be run at full scale with basically all the flows, 252 or whatever million flows background, 4 million left unused for the CPS test, with a CPS test running at 25, let's say 25 million CPS, the requirement is 24, and all of it running. So this is a demo of showing the full hero test running.
Yeah, that's amazing. I don't think I've ever seen this before, Mircea. I mean, we started 2 years ago looking for this kind of scale, and I didn't know that we were. I mean, I figured we'd get there, but this is awesome. Does anyone have any questions on the call?
Maybe I missed it, or maybe you're not at liberty to say what hardware is behind this.
I can talk about the test hardware. I'm not gonna talk about the cloudy thing here. I made it like this. It's just test ports. We send 4 ports of 400 gig that aggregate all this traffic and send it to the device that you want to test. Now, there are 2 public demos that can be seen, and maybe we can link them here and so on. I believe at OCP, Intel did a demo, and also Cisco with AMD Pensando and Microsoft had another demo. One was for a DPU and one was for the smart switch.
Yep, we did. I think
So those are two known, public demos.
Yeah, I think the public one we showcased 12 million connections per second. We knew we could do more, but that's what we put out there.
Thanks.
Mm-hmm.
Any questions regarding the test itself and the testing part?
So it's none from me. It looks like none from anyone else either. So would it be possible to link this demo to the GitHub repo at some point, Marcia, or I can do it?
Yeah, if you would like to do it, I mean, you are recording this meeting. I don't have a recording. This is all live,
Yeah,
so
yeah.
this is a
I'll do
recording
it.
of the meeting.
Yeah,
Yeah.
I'll do it. Yeah, and of course
Then
it'll always be on. Actually, it's usually on YouTube for everyone who doesn't know. I post these to YouTube, so that should be in the notes next time. This is awesome.
Yeah, and for HA, just another note for HA, if we have another, let's say, cloudy thing, this here connected to another 4 ports, we can live move the traffic from these ports to these ports without losing any packet from the test tool. And basically the backup, it's going to see the traffic instantly. And we can set that and we see how well.
Is this a high availability
No.
feature?
I was saying for HA, we can do that also. This is not for HA. This is just CPS hero test. And I'll stop the demo. And this is outside of the demo. From last week, I had a question about HA, and I think I pointed to the wrong item. It's the ticket 57 in Dash. I know, Christina, if you want to share, or I don't know if now it's time to talk about it, or you want the other presentation to go on and we can talk about issues later.
Let's go ahead and go on, and we can talk about it later.
Okay.
About that. Okay. Well, thanks, Marcia. That's awesome. We also had another today. We have Michael here from the software-defined networking team, and he wanted to give a quick look ahead at a feature he's been working on.
Hey guys.
Hi, Michael.
I'm assuming you can hear me. Hey,
Mm-hmm.
I want to introduce you guys to the concept that we were discussing before, that we said that we introduced to the Dash community, which is called floating Nic. And the concept that we were working on a lot in our backend, doing different prototypes. And right now I think we are ready to kind of introduce it to the community to show how we can do that on smart switch and what's the idea of the floating Nic. So I will share the screen on this one. So you guys should right now see. Krista, can you see? Perfect. Awesome. So first, how we get to the floating Nic and the idea of how the Dash right now works. So the current Dash that we have and the current pipeline that we have is all about accelerating VMs. So it is all about, and I will slightly zoom it. It's all about basically accelerating VM. So we have basically this accelerated VM that is behind Smart Switch GPU that is not doing any rule processing like we were doing this before, but everything is rule processing in the Smart GPU. So every time when some packet, for example, from the rest of the virtual network or from the internet, I call it like this first cloud, like VM1, is trying to reach the VM, it always goes through the smart switch DPU on this kind of like one of the pipelines. The smart DPU basically will evaluate all the rules, and once it evaluates, for example, inbound ACOs towards the VM, will then deliver traffic to the VM on something that it's kind of like dedicated tunnel with one single GR key that basically I called it last mile. That delivers to the VM, right? In the same thing, like when the VM later replies to this packet, or whether the VM, for example, initiates new packets, right? The VM will basically put the traffic out. So basically originate the traffic, and the traffic basically will go out to the smart switch DPU, which will evaluate all the policies that normally the VM will have in the outbound case, just evaluated in the DPU, so it's kind of very, very fast, and then basically send the traffic either to the original VM1 if it's reply, or for example to VM2 it's initiating of the connection or the internet, right? So that's the existing dash, and how right now we model the dash in the community, because the main idea was to accelerate VMs, right? So the main idea was that previously all this rules evaluation was happening in the software, in like some kernel drivers, and it was very, very slow. So it impacted connection per second rate, and that's why we kind of, as part of the smart switch program and the dash program, we kind of move it to the actual DPUs. So all the basically packets that VM originates are always intercepted, move to the smart switch DPU, and then this is where the policy is evaluate the outbound inbound, right? But one thing that we noticed later is that do we even need to have a VM for some of the scenarios, right? So the idea that none of the cloud introduced yet is this idea that how about, because those are in the form of smart switches, which are actually routing appliances by itself. Just the normal switch basically routes on the physical network. Smart switch can route in the SDN layer, right? If only small routing is needed, and I will later tell more about the scenarios that we will basically plan to enable behind this, right? Then maybe sometimes we don't need this VM, right? Because like, for example, this VM is actually customer-facing VM, which is actually, for example, serving websites or serving some applications that needs to be doing this in very, very performant way. Then yes, the VM needs to have some customer functionality, and that's why we are basically rule processing that is offloaded to the dedicated DPUs. So this VM can do it, right? But if we need to basically put the appliance just to, for example, provide access, let's say from the on-prem, right? Or for example, quickly switch traffic that, for example, will be going from the VM1 to some one location or the other location, right? To be able to kind of pass through those. And here the concept is kind of like NVA, I would say. So for example, if this is like the NVA that implements, let's say, firewall functionality or some packet inspection functionality, this kind of stuff, right? There are different level of NVAs, right? And for example, some of the NVAs are implemented on custom the packet inspection. Yes, sometimes the NVAs are being used to, for example, route traffic, just mostly bounce the traffic out, right? In this case, we really don't need the NVA. So what we want to introduce is something like a floating mode, which is basically the same kind of pipeline that we have in Dash, just that it's basically hairpinning the packets inside the DPU, right? So if, for example, normally, let's say VM1 will be communicating with VM2 through a purpose, and if the existing scenario, for example, the VM1 will send the packet to smart switch DPU, will evaluate some policy inbound, deliver to the VM, right? But let's say the VM doesn't do anything with those packets. Let's say it just bounces this out, right? It will basically bounce out those packets. We'll evaluate the policy outbound and go to the VM2, right? In the same thing that we want to achieve here, if the VM is really just bouncing the packets, right? Then we actually don't need the VM. We can bounce the packet just on a smart switch, and this is what we call floating, right? So the idea is that in the first diagram there was actually VM that was inside the VM was doing bouncing the packet, but the packets were arriving to the VM through this NIC, which was kind of accelerated on smart switch DPU. Here, if we think that, hey, there is a NIC that has those policies, right, but there is no VM attached, that's why we call it a floating NIC, because it basically floats in the cloud like this without the VM, right? And this is the concept of floating NIC. So we can potentially deploy a DPU that works in a way that if the VM1 sends the traffic to, for example, VM2 through some like next hop, and previously the next hop will be like VMIP, and now we can and the VMIP is always attached both inside the VM as well as on a DPU, right? The idea is that if we have a DPU, this DPU anyway advertises this IP, so VM1 then needs to send the traffic to a VM2 through, for example, this IP that is assigned on this NIC. We'll just send this. It will go to the smart switch in one direction, evaluate the policy in the same way that it was evaluating as if it was going to the VM, right? But then don't deliver to the VM, just bounce it out, right? And then evaluate outbound policies, right? And redirect wherever the outbound policies are doing, right? This can have a purpose of, for example, when there is like two VNets peered to each other. Let's say, for example, VM1 is from one VNet, VM2 is in the second VNet, right? They can definitely send the traffic between each other. But if you want to, for example, inspect all the traffic and apply some ACLs, let's say all the traffic going between, for example, one VNet to another VNet, right? Usually those ACLs were being applied on some like device in the middle. In this case, for example, we can intercept all the traffic that goes from VM1 that needs to go through, for example, entire VNet VM2 and saying redirect to this IP of this NIC, which will be served by the DPU. We'll go to the DPU, evaluate packet on the inbound, bounce the packet out, evaluate packet outbound, and go to the VM2, right? So it's kind of lightweight NIC that serves exactly the same purpose and have exactly the same policies that previously the NIC that had the VM, just there is no last mile. Right, so that's the definition. That's the concept of the floating NIC. So basically, the NIC that serves the same purpose as the accelerated NIC just doesn't have a VM. Everything bounces out. And with this few potential concept of the scenarios here, right? So one of the scenarios that I mentioned is kind of like, for example, the NVA that needs to inspect packets that are going between, for example, different, let's say, virtual networks, or between, for example, one on-prem and the other on-prem, right? When there is source VM that has a NIC, it normally will originate traffic, will intercept using route table that is assigned on the source side, saying, hey, intercept everything, for example, that goes to the destination through some NVA, which NVA has a NIC, right? The NIC is doing normally like some ACLs and routing, right? But it does that ACLs, right? NVA, in our case, if it's accelerated NVA, the packet will get delivered. We'll need to potentially do something else, right? But normally NVA will just bounce the traffic out. And then the NIC will also have policies that normally are applied out and delivered to the destination, right? But if you want to have very NVA with big functionality, then NVA will still exist, right? If you are just okay with, for example, having lightweight ACLs and routing functionality, so the kind of functionality that you can apply to the NIC, and you just want to have NVA that bounces the packet, right? Then really you don't need an NVA. You can fully accelerate it on the floating NIC, right? And this has multiple concepts, because one of the concepts that we can use floating NIC is also to have the NVA to be also smarter than NVA to kind of control this floating NIC. So even though, for example, there is a floating NIC, the packet goes through the floating NIC, right? We can always introduce the concept that this NVA will somehow control and configure dynamically this floating NIC. So there is a control plane that, for example, customer can also develop this kind of like NVA control plane. They will dynamically, for example, also manage the policies of the floating NIC, but all the stuff of the packets going through can be fully accelerated, right? So think of this, guys, that this floating is kind of like a router in between that can be used lightweight router, both from the customer as well as infra. That is basically doing all the packet processing in this kind of more accelerated way on the DPU, right? And one of the example scenario how we can use it, and this is how we, for example, provide right now connectivity, for example, for private link from on-prem. So in this diagram, this existing scenario of how actually customers connect from on-prem to Azure and different services in Azure, right? So usually in on-prem, customer has their own address space, right? So those clouds above signifies customer on-prem, right? Usually the customer on-prem is connected through Azure or any other cloud provider using, for example, some MSC devices, right, which provides the termination, right? But once the traffic arrives on the MSC devices, because Azure is very heterogeneous, right? Those MSC devices later, because they are normal physical network routers, so they are not smart basically switches, smart routers, right? They don't have a concept of, hey, this, for example, on-prem belongs to, for example, one customer versus the other. And if, for example, later, this is, for example, let's say Coke versus Pepsi, right? If, for example, one customer needs to basically access through the on-prem their own virtual network, then normally we need to encap the packet and introduce this SDN layer. And this is usually what clouds do. They will, for example, the raw packets that are coming from on-prem will hit MSE. And then after MSE, they needs to be redirected to some devices, which just will do the SDN encap to introduce the virtual network layer to later redirect to actual VMs inside Azure, right? And this is usually, at least so far, was provided by a set of dedicated devices, which usually were highly accelerated VMs. And the only purpose that the VMs were doing was kind of the MSE packets were directed directly to this FNIC gateway VMs, which we call them. They were just doing very, very lightweight packet inspection, bouncing the packet out on this NIC, right? And this is where all the complex SDN scenario was happening. So all the routing, route tables that customer had was being implemented, right? All the ACLs, yeah.
The mappings and all that.
And the mappings, exactly, right? And this was going to the private links, right? But those VMs were usually just consuming compute, right? Because if you guys take a look at how clouds are constructed, clouds are usually, for example, have in data center, right? Have basically racks of machines which are like heavy compute based, right? Which is basically lots of compute there. They have lots of machines which are, for example, heavy storage based, for example, for building storage, right? But really, data centers till now didn't have a concept of, for example, the racks that are heavy networking based for the networking stuff, right? The kind of networking stuff was either implemented on normal physical network switches, right? Or set of dedicated machines which were kind of optimized for the networking, but at the same point they have lots of compute. But at the same point, the compute was usually not used on those machines because those were running, for example, the PTK application that can be right now fully accelerated on the TORs. Because the traffic anyways goes through the TORs, right? So those VMs were, for example, using lots of compute. From the cost perspective, the compute is not needed here, right? Because we need, for example, the NCAPs to the VNet. So those VMs can actually be replaced by some dedicated DPUs, which just will be doing this packet bouncing, which is basically the DPU that acts as a floating NIC, right? So in this case, the gateway here is this kind of gateway that can program this floating NIC from the side, can program all the routing rules and all the ACLs, right, to the DPUs. But then the DPU, the traffic will just go to this DPU, evaluate policies on the inbound because you need to inspect basically the MSE traffic on the inbound, right? Then on the outbound, we'll have another policy which will basically evaluate the ACLs on the outbound scenario, apply routing, and then, for example, deliver to, let's say, private link service or deliver to a different virtual networks inside Azure or VPCs, right? So basically, that's the concept of the floating where it can accelerate, right? So it's not only about basically accelerating VM, which DPUs are doing right now very well, right? But there's lots of scenarios where we actually don't need the VM, we just need the routing stuff, right? We can even optimize the DPUs and not have this additional path when it's kind of like we call it last mile to do DPU, but the VM DPU can inside do herping. If we configure this DPU with the last mile mode or not last mile mode, this kind of floating mode or not, right? And then do inbound policy and outbound policy. So that's kind of high level concept.
Yeah. And I think, Michael, this just what I want to reinforce is that, again, we're removing the policy, the inspection, and the routing away from the software layer, how we're doing it today with VFP, GFT, and we're getting like enormous amounts of scale improvement doing it this way. Would you agree?
Yes, I fully agree with this one, right? So this is huge improvements, right? And this is kind of like in addition to the current offering of the accelerated NVAs, which customer can right now do using the DPUs, that this is their customer NVA that they want to do, right? They right now will have ability to kind of deploy the NIC and configure it from the side, right? And for example, redirect only specific traffic to be, for example, inspected by the NVAs. So think of this, that in this case, the customers or the vendor providers who, for example, own the NVAs can actually program async through the control plane, for example, those DPUs, where they can say, okay, for example, first majority of the traffic, for example, so should read the DPU, then, for example, offload some rules saying that, hey, right now configure the policy slightly differently for some of the packet once being fully inspected, right? Or even configure this in fully way, like, for example, we'll be doing in Azure to for example, provide the on-prem connectivity, this kind of stuff, right? So this is this kind of stuff that for example, from on-prem will be going to the appliance, which we call appliance, but right now will be like DPUs and smart switches, right? Previously it was community appliance, and then go to specific private link service, doing all the NCAPs, right? So the existing pipeline that is there, that was previously modeled, hey, there is the VM, and the VM here was actually the accelerated VM that was here as the last mile, right? So the VM is basically when it outreaches packet out, it goes here, goes to the network, right? And then when the network outreaches packet, it goes to the VM. The idea here with the modification is that this pipeline still exists, so the network outreaches the packet, goes through this kind of stuff, but before delivering to the VM, it's just supposed to do hairpinning, so kind of reinject packet on its own pipeline, and as if basically the VM just did a simple hairpinning and do through to the other routing, lookup, this kind of stuff, right? So in this part, there is no cost associated with actually going to the path to the VM. There is no additional NCAP there. There is just simple harping of specific traffic that gets re-injected, and the packet basically arrives from the network, gets hairpin, and basically leaves to the network. And based on this, we were able to prototype some of the scenarios like a private link service on the floating IP. So kind of virtualize some of the scenarios that we have, for which previously, I'll not talk more about this. I can potentially use some of the next sessions to kind of describe if people are interested, right? But the idea is something that previously we had like private link service, which was doing, which was actually where the IP was assigned, right? But we didn't really use compute. We were using policies there, right, to kind of do this kind of like SDN and this kind of stuff, right? We no longer need to do compute. We can kind of implement it as a kind of floating IP. So this enables basically lots of scenario just by the simple hairpinning of the traffic inside, for example, DPUs, right, to kind of optimize the pipeline, right? So that's basically the idea of the floating concept. And with this, I will open for the questions.
For questions.
Yes. Yeah. And I believe we also have a paper for this. So if you guys are interested, MSR team, I think this year we also publish a paper of this concept, because we have we have some prototypes going, but definitely will be good to basically see it on the DPUs, because this is where the concept is very powerful, and I think this will be like the first time when we can actually introduce the routing appliance that is actually routing appliance for the customer to use, right? Because so far the routing appliances were actually the actual VM with huge compute, right? Right now there will be a concept of the actual networking routing appliance, which DPU will be using. First will be using for infra, right? Later will allow functionality that, for example, NVA vendors can use it to accelerate their workloads by kind of not going through all the packets through going this, but going this kind of stuff that we have also doing kind of like a side channel, when they can either program statically this kind of routing devices, right, and intercept only some part of the traffic, or program this more dynamically later, right? All the scenarios, like for example, VTAP comes into the picture, that you can have a VTAP NVA that for example, in the floating NIC, which will be routing packets very, very fast. You can say that, hey, tap this part of traffic. So basically different types of traffic will be routed differently, right? You can, for example, if the DPUs have an encryption chipset, you can say, hey, encrypt this traffic in this way, encrypt this traffic in this way, right? So all the basically routing policies, which are routing heavy, not so much compute heavy, can be implemented with the floating NIC, and the compute can be configured both by the Microsoft and also vendors as kind of side channel, where they can also optimize how the compute is being used, right? So it means that all the NVAs can be even accelerated much, much more, because it's not only like all the packets will be going through the NVAs, but the smart switch can be configured that only selected packets can be going through the NVAs, right? So you guys can think that the NVAs can even scale much, much more than the current compute scale, with basically single cost of the single basically compute, and there is additional like kind of model that NVAs can build on top of it, from the billing perspective, because we more accelerated NVAs, so NVA vendors can basically sell it for the higher price, but at the same point underneath have a cost of, for example, only single compute that is being deployed, right, and provide more acceleration. So there's lots of cool scenarios that can be developed by having kind of like programmable DPU that is not working the last mile that is working as the floating. So that's the idea. And we would like to basically part of this like standardize also as a dash. Most likely this will be just the flag saying like a floating mode true or not, which will basically, or hairpinning true or not, which will basically introduce the hairpinning, which means that right now that there is no hairpinning this last mile, right? Once we flip this mode on the NIC, then the DPU will be just basically doing hairpinning. It's kind of like instead of going through the VMs and going back, we just basically introduce the hairpinning, right? And we can even think of something that we're prototyping on our side, potentially a mix mode, that the hairpinning may happen, for example, for majority of the packet, apart, for example, let's say specific IPs, which can be based on the configuration, which means that we can still have, for example, the NVA, that, for example, some of the packets only will be going to the NVA based on some configuration, right? But for example, most of the packets will be harping, this kind of stuff, right? But I think that's the concept. Main thing they would like to introduce is kind of like mode that will be like true false with regards to whether it's floating in a hairpinning mode, right? And then potentially in the future we can figure of adding some configuration on top of it to kind of figure out if we can. You also want to make it the mix mode that some of the packets will be hairpinning, some not, right? But that's the concept.
Yeah, and I think that people in the community, if you have scenarios you'd want to, offer up or explore, through floating NIC, that could be interesting to the community too, right, Michael?
Yes.
Yeah. And so typically the process is we have this information and we will flow it through engineering over to me, and I'll go ahead and put it in markdown format and kind of put it in our repo. And so that's how that would work. And with respect to the MVAs, I just want to point this out. What's interesting, because we are using this internally, my peer, James Grantham, works on the Sirius appliance. And so with the NVAs, it's interesting. We actually have Keysight helping us, and the method to measure the connections per second on the NVA layer, both internally and with our customers, has been very, very helpful for apples to apples comparisons. So just want to say they know how to help us do that. Right, Chris?
Yes. Yeah, and one additional stuff I want to also.
Yeah.
Cool. Yeah, stuff that I want to add for the point of view of smart switch working in this kind of like the mode of the floating NIC, right? Is that you can actually stack this out next to each other, right? So you can also, for example, configure one smart switch with the routing policy outbound, saying that, for example, spread the traffic using the ECMP that we already have in the current Dash definition, saying like use the ECMP to spread the traffic across, for example, multiple devices, right? So it's kind of level of ECMP on the SDN layer, which previously ECMP was only kind of done in, for example, the physical network layer, right, which basically switches were doing ECMP only for the next kind of across basically all the links to the switch, right? Because here basically we have a SDN layer on top of it that can do the NCAP in the routing, right? The ECMP can be done, which is already done. For example, if we have the idea of like traffic going through the MSE, right? We have this kind of ECMP against those that there is an VX NCAP that basically sometimes goes here, sometimes goes here. We already have this definition in Dash, right? But the idea is there was still always the concept of the VM, right? But we don't need to have a VM. We can basically put this smart switch floating NIC in front of, for example, let's say software load balancer, which previously, for example, all the software load balancers instances were receiving traffic on the because they were advertising, for example, NIC as IP, right? So in this case, physical network TORs were kind of redirecting traffic equally to this NIC as IP, right? But there was no way to kind of do intelligent steering, for example, right? And software load balancers always had to introduce this additional layer of, let's say, additional set of instances that were doing this intelligent steering, but those intelligent steering was always basically the VMs, which was heavy on compute, right? Running some like DPDK application, BFD and this kind of stuff, right? BPF, or even normal drivers, right? Right now, this acceleration can be done in a much cheaper way, I would say, and much more scalable way from the performance perspective using basic smart switches. If we configure this in the DPU, because in the floating NIC mode, because we just will not need to have, we don't need to pay for the cost of the the compute, right? For doing this kind of stuff. So you can actually stack them to kind of redirect traffic differently in the cloud or data centers and this kind of stuff. Yes, exactly.
Yeah, and return to compute so they can use that for other activities and basically offload the network processing. Yep.
Yes.
Yep. Yeah. Thanks, Michael. That's awesome. Guys on the call, do you have any questions for Michael or the concept before we go today?
Mircea here. I have a question.
Sure.
What about the hybrid scenario where you have this NIC, but you also want a VM, and let's say you have 4 functions, 3 are accelerated, so you don't need to reach the VM, but one, it's not accelerated, so you want to do it in the VM. How would you do that with this scenario?
So depending how to define functions. So for example, if the functions, because the VM can have
routing,
basically just
I don't know. And
yeah. So the VM can always have, for example, in this case, you don't need to have a VM like with one NIC. You can have, for example, VM with basically, sorry, with multiple NICs. You can have a VM with, for example, one NIC, and one NIC will be actually modeled in this kind of mode, and the other NICs that were previously on the normal like NVA, which were just, for example, routing traffic, can be modeled directly on the DPU, right? So you can still create VM with multiple NICs. Just for example, one NIC will be attached to the VM, the other NIC can be floating, right? And you can kind of configure it on the side, right? So you have this idea that not all the NICs needs to be attached to the VM, right? Or even if they are attached, you should be able in the floating configure this policy of which packets are actually being hairpinned versus which being basically delivered to the VM. And we also have some thoughts in the future to potentially introduce some API, most like a packet-based API, that you can actually use this smart switch to kind of like say, hey, please offload this flow. So once the flow basically comes here, you can say please offload, but this is a different concept of the floating, right? This is more like building on top of the floating, kind of like a stuff to potentially have the VM to control which flows to offload, to kind of accelerate the NVA even better per flow.
Okay, so basically two NICs. You cannot have one NIC. One second. You cannot have one NIC that says this traffic is hairpin and this traffic actually needs to reach the VM.
You could. So in the floating mode, when we add not only flag true or false, but also a list of IPs, right? And the configuration, then you can decide, hey, those IPs should be basically hairpin versus not, and deliver yes, right? But we are more thinking that there is one thing like basic configuration, but we are also thinking in the future we potentially want to have the packet-based configuration that the NVA can actually accelerate and send specific packets to potentially offload those specific flows. And you can think of this that, for example, the NVAs which right now doing, for example, IPsec tunnel termination, right, and all the validation, this kind of stuff, right? Currently, they are not only doing IPsec tunnel termination, the NVAs, but also, for example, once the tunnel is terminated, they are always doing this encryption, right? If the DPUs have the cryptographic processor, you can think that, for example, the first packet that doesn't have the flow will still be reaching here, but then you will design some packet-based protocol, but it's more different than control plane dash, right? Packet-based protocol that basically will say that, hey, once you receive this packet from the trusted source, from this like last mile VM, please offload this flow and do this specific transposition. Let's say always do encryption with a specific key that was negotiated or something like this, right? So then the NVAs can be even accelerated more in this, right? So this floating is really introduced the concept of hairpinning, to be honest, right? We definitely want to control it through the flag, right? Potentially also in the future, potentially maybe per packet as well, to kind of enable even more cooler scenarios for the NVAs. But for now, I would say just the flag. So that from the infra perspective, we can accelerate all the on-prems and all the kind of like load balancers and this kind of stuff, right? But in the future, potentially work together with NVAs to design the packet format to even offload specific per flow hairpinning, right? So by default, everything will be, for example, going here, but for specific hairpinning maybe per flow, this kind of stuff. That's kind of concept in progress based on the floating, right? That we can provide huge benefits for the entire like vendor ecosystem and software vendors ecosystems that they can actually use all the cryptographic processors or anything like this that will be later with those DPUs.
Yeah. So basically, Michal, if you
you.
look at the pipeline, the pipeline is different from the VM pipeline. So so basically, if you need certain things to be in the FloatNIC side, then it's a FNIC basis. That's why it's like that. But depending on the scenario, you may be able to achieve the same thing using the FloatNIC pipeline. You know, achieve the similar stuff. So
yeah, and the pipeline want to make sure works exactly the same here. The VM is really a VM NIC, right? So basically, the entire pipeline should kind of both in both direction when they do harpening, right? And I noticed, Christian, you are also unmuting yourself somewhere, so you probably have also some observations, questions.
Yeah. Thanks, Michal. I have two questions. First, is this a feature that is already deployed, used within the Azure data center, or is it just a new feature that we want to prototype in SONiC and see how it works? That's the first question. Second question, you had the pipeline over there. It would be good to understand where would the pipeline change, the current dash pipeline for VNet to VNet change? Is it just the routing block, or is it just the VM side and no change on the pipeline in itself?
So no change of so the only change on pipeline, think of this, that basically there is no VM and this just does harpening, right? So when you do harpening, you no longer need to do this VNI lookups or ENI lookups, because you know on which UNI you send it and the same ENI basically gets returned, right? So usually this is basically that the VM will be replaced with the harpening. That's the change from the pipeline, right? From if this answers this question.
Yeah.
The second question, yeah. And the first question, whether we have this deployed, we have prototypes right now, and yes, we have prototypes of this, and the prototypes are mostly right now for our on-prem connectivity, and this potentially something with the PS FloatNIC. So based on those prototypes, we know that this works, and we know there are huge benefits of those. So that's why we want to right now move out of the prototype phase and actually have it fully implemented in Dash and in this case of the smart switches, right? So that's the stuff, right? We usually don't propose stuff which we didn't test it before, because then it will be kind of waste of everyone's work to basically deliver something or have something that nobody will be using, right? We always want to prototype some stuff, make sure we hit the acceleration that we want. And that's why we go for this, and that's why, for example, part of the concepts for the smart switch, apart from Dash, will be potentially to introduce also bring your own data pad that potentially the data pad can be running like a P4 pipeline, that we can kind of do this right now. The bring your data pad is mostly like DPDK that we have on community appliances, how we can kind of prototype some of the solutions. But having this ability on the DPUs will be also very useful as well.
Yeah, thank you.
And just one more addition to what Michael mentioned about the pipeline is that the pipeline is probably a little bit more than just the harpening, but we will come up with a doc describing the pipeline. So for example, like the flows will work slightly differently, so a little bit here and there, but we'll come up with a doc. Then we'll fully
yeah, I mean, yeah, flows can be optimized more potentially, right? But because there will be never a scenario when the VM will be originating the flows, right? It will be always basically some stuff from the network. They will be sending first packet based on which basically we're going inbound policy, then happening outbound policy. So basically the VMs will never be originating the flows. Potentially can be optimized out, but this kind of traffic that normally VMs will originate the flows and go through outbound ACLs, right? This needs to go just for the hairpin packets. We'll go through basically outbound ACLs, right? So outbound ACLs are still there. The same as inbound ACLs. When the network comes to this, goes inbound. Normally we'll go to the VM. That VM will send reply and go through outbound ACLs. Here, the outbound ACLs still want to have it evaluated. So there will be some potential optimization that we can do on top of it, right? But so that I will work with Reef and to kind of define this as actual definition and kind of potential way how we can do update, potentially some optimization inside the VMs and this kind of stuff. Inside the DPUs, yeah.
Yep. Just yeah, we'll send the doc out like later. Yeah.
Cool. Yeah.
Yep. Cool.
Yeah, and just I want to emphasize that like till now, right? All the kind of innovations were always within the clouds, right? And right now it's kind of pretty cool that basically all the cloud innovation at SDN, we are actually going to the entire community so everyone can benefit. So it's pretty cool stuff that we do see lots of innovations happening out of this program in general as part of this program. Right now, for example, the prototype concept of the floating that we are introducing to the ecosystem and this kind of stuff, right? That can definitely change how the networking is done and potentially build lots of new businesses and lots of new scenarios on top of it, which would be pretty cool. I would say, right? And like normally in the data center, there was kind of like so far compute heavy nodes or compute heavy machines, storage heavy machines, right? We'll have a actual switch heavy, like in a smart switch, kind of like networking heavy machines, kind of like dedicated SKU, which will be actually not machines that will have like compute that nobody uses, but the actual DPUs on which both infra and customers will be able to define their own scenarios. That will be actually pretty cool innovations, I think, that this stuff is driving. And Christina is driving the entire dash, so pretty cool.
Yeah, well, thank you. I know this is a lot to throw at everyone today, so maybe take it back, think about it. Maybe we won't come back next week because that's Thanksgiving holiday for United States, so I'll probably cancel next week. But if you have questions or comments, come back maybe the Wednesday after or shoot them over and we can talk about it more. It looks like I can give back about 6 minutes of time today. And I want to say thank you to Mircea for demonstrating